Okay, lesson 4.4 is solving a linear equation in the form of ax plus b equals cx plus d. This is very similar to what you've seen before of ax plus b equals c. It just has a little more complexity to it, and we're going to work our way through that. Okay, so the big idea is that ax plus b equals cx plus d can be solved with just one more step than the one that you're already familiar with, which is ax plus b equals c. Okay? Here's the practice work that you're going to do. And I said in the assignment in the practice work, make sure you show a complete check in problems 7 through 13, or 7 and 13, 7, 9, 11, and 13. Because what that means to be of a complete check is that when you're all done, you have a number here and a number here, and they're equal to each other after you've done the complete check. Okay? You shouldn't have to have anything where the person reading your work has to figure anything out. Okay, so 4.4 starts with this idea, and I took this right out of the book, is that an important problem-solving strategy in math and in other fields is to take a problem and turn it into a simpler one, okay? And a simpler one that you already know how to solve. And that's typically what I'm showing you when I talk about the easy button. We take something that we know how to solve and we adapt it to a problem that we're struggling with, okay? That's the idea that they're going to use for looking at this new equation. They're going to say, take this equation and turn it into something that you know how to solve already. So turn ax plus b equals cx plus d into ax plus b equals c. Okay, and then just as a reminder, let's talk about what all these things are. In the language of math, a, b, c, and d are known quantities. They're numbers. X is the unknown, the thing you're solving for. Okay, so using algebraic processes, let's turn ax plus b equals cx plus d into ax plus b equals c, and then at that point we can obviously solve for x. Okay, so what the end goal is solve for x. Okay? All right, so if we want to get x to be an integer, and that's our goal, well, let's look at what we have right now. What do we have right now? We have ax plus b, where ax is 16x and b is negative 5. Okay? Cx is 10x and d is 19. Okay? So that's what we have now. What do we want to do is we want to annihilate Anna, like we did before in the other lessons, and now we made a new one, and I called it Crush Christina. Sorry, Miss Hagen. All right, so we want to get rid of ax or cx, and the or is what we're going to talk about in this lesson. When is it that you want to get rid of one, and when does it want to get rid of the other? Well, the best way to approach it is look at which one's smaller. Is ax smaller or is cx smaller? And when you annihilate them or crush them, annihilate or crush the smaller one, either ax or cx, so that when you get down to ax plus b equals c, you don't have a negative coefficient any longer. All right, let's see how that works. Okay, so that's what we're trying to get to. We're trying to get to solve for x. We want x to be an integer. Okay? We have this guy. 16x minus 5 equals 10x plus 19, where ax is 16x and cx is 10x. All right, now let's do this right-hand side first. Okay? So what if we crush Christina instead of annihilate Anna? So if we get rid of 10x, because that's Christina, okay? So here's our original equation with the 10x taken away from both sides. So it becomes 16x minus 10x minus 5 equals 10x minus 10x plus 19. And then the right-hand side becomes 6x minus 5. I'm sorry, the left-hand side rather. And the right-hand side becomes 19. That is now in the form of ax plus a negative b equals c. And that's an easy problem for us to solve. We just add 5 to both sides, and we get 6x equals 24. And then we kill Bill by dividing both sides by 6, and we get x equals 4. Okay? So in this case, we subtracted cx from both sides at the very beginning. Well, that's actually what we wanted to do, because that worked out really nice, and we didn't have to deal with any weird negatives. But watch what happens if we hadn't done that, and we had annihilated Anna instead of crushing Christina. So here we are back to the original equation. Okay? What if we had subtracted ax instead of cx? All right. So we would have subtracted 16x from both sides. That would have made it go away on the left-hand side, and we would have only been left with negative 5. On the right-hand side, we would have gotten negative 6x plus 19. Okay, it's not the end of the world, but it's getting a little ugly. Okay, so what do we want to do now? Okay, well, we want to get just an integer on one side, okay? All right, so we want to get rid of the 19, because right now we have negative c equals negative ax plus b. That's what that is right now, right? So we want to kill Bill, and Bill is 19, so we're going to subtract it from both sides. So we get negative 24 on the left side, and we're left with negative 6x on the right side. Okay, now we want to get rid of the negative 6x, so we're going to divide both sides by negative 6. And negative 24 divided by negative 6 gives us 4, and negative 6x divided by negative 6 gives us x. Okay? So, what happened in both cases was we got x equals 4. But this time, we had to deal with a bunch of negatives right through here and right through here that we didn't have to do if we just focused on what is the smaller ax or cx. And in this case, it was the 10x was smaller, and so it made the problem easier to solve. Okay, now let's look at one that requires a distributed property, okay? Because they're not always in the perfect form of ax plus b equals cx plus d. Sometimes you have to turn it into that form and then turn it into ax plus b equals c. So we're going to solve for x, but we have an equation that's got the distributed property in it. So the 7 minus x plus 5 becomes 7 plus a negative x plus 5. And the right-hand side stays the same, 4 times x plus 11. Then we take the negative and we distribute it to the x and to the 5. Okay? So we get 7 plus negative x plus a negative, 7 plus negative x plus negative 5 equals 4x plus 44. And then we commute them around just so that the 7 and the plus negative 5 are next to each other. So we get 7 plus negative 5 plus negative x equals 4x plus 44. Combine the 7 and the negative 5 together, and we get 2 plus negative x equals 4x plus 44. Okay? All right, so now we finally have it in the form of ax plus b equals cx plus d. This is actually b plus a negative ax equals cx plus d. All right, and then we can look at what's the smaller x. Is it this guy here, or is it this guy here? And clearly, it's the negative x, not the 4x. Okay? So since this guy is smaller than that guy, that's the one we want to get rid of. Well, we're going to get rid of a negative x by adding x to both sides. Okay? So when we add it to the left side, it goes away, and we get 2. When we add it to the right side, we get 5x. So the result is 2 equals 5x plus 44. And now we have it in the form of c equals ax plus b. And we can kill Bill, which is 44, by subtracting it from both sides. And then we have negative 42 equals 5x. And then we can annihilate Anna, get rid of the a, by dividing both sides by 5. And on the left-hand side, we get negative 8 2/5. And on the right-hand side, we get x. Okay, and then the last thing the book wants to show you is a word problem using this ax plus b equals cx plus d form. Okay, so they give you the situation where you're breeding dogs, and one of these breeds, whatever it is, at birth is 14.8 ounces, and it's gaining half an ounce per week. The other breed starts out at 11.6 ounces and gains 0.9 ounces per week. Okay? Well, that's what we know in the word problem. What do we need to figure out is when will they be the same weight? So we need to set them up as an equation where 14.8 is the constant plus the coefficient of 0.5 times the number of weeks equals the constant 11.6 plus the coefficient of 0.9 times the number of weeks. Okay, so that's ax plus b equals cx plus d. And then we're going to get rid of the one that's smaller. In this case, it's 0.5. So we'll subtract 0.5 from both sides. And we get 14.8 on the left side and 11.6 plus 0.4 on the right side. And now we have c equals b plus ax. And we can kill Bill and get 3.2 equals 0.4w. And we can annihilate Anna. And we get weeks equals 8. So at 8 weeks, the puppies are the same weight. Okay, so then in summary, remember this was the original idea that they put at the beginning of the lesson. If you can turn something that you're unfamiliar with into something simpler, then you can solve it. The goal is still to solve for x. You have this more complicated version, and you can use properties to get it to be this version. Okay, and you do that by either getting rid of ax or cx, whichever one's smaller. And then once you have it in that version, you just kill Bill and annihilate Anna, and you'll have x.